morning we have Michael Widderick and Annie van der Meulen from the Queensland Department of Agriculture and Fisheries. They are research scientists there, and they're going to show us a presentation today which is all about non-herbicide weed control tools for that part of the world, for sort of Queensland and northern New South Wales, that northern cropping zone. So good morning, Michael and Annie.
Good morning, Peter.
Good morning, Peter.
Well, it's not morning in Queensland, is it? Sorry about that. So I'll hand over to Michael. Michael's going to speak for a while. Annie will also come in and they'll swap between them and do some presentations. And as I said, we'll pause for questions as we go. But I'll hand over to you, Michael, let you go through what you've got to present to us for a while, and then, yeah, we'll pause as we go.
Okay, thank you very much for that, Pete. Okay, this afternoon we're going to be talking about the topic which non-herbicidal tools are a fit for the northern region. Often when we think about weed management, it's very easy to straight away go for the herbicide drum. So the focus of today's presentation is to hopefully give you some ideas of what other options are available for effective weed management. So when we're talking about the northern grain region, you can see there on the slide, I've circled the area that goes from central Queensland all the way down to the New South Wales Victorian border. Across this region we do have a rainfall that really ranges from winter dominant into the south to more of a winter-summer shared rainfall in the north. So we do have a diverse range of cropping options available in the region. We also have, though, diverse weed problems. In a 2011-2012 weed survey, we actually identified over 70 different weed species that were infesting our crops paddocks. So we do need diverse weed management solutions. We will talk later about the importance of this, but in brief we've got chemical and non-chemical options, and I'll go through what these are now. The current state of play in the northern region is we do have reduced or minimum tillage systems, so a conservation agricultural system where we're heavily relying on herbicides. As a result of this heavy reliance, we now have herbicide resistance, which is becoming more and more widespread, and we also have many difficult to control weeds, and one that jumps to mind is feathertop rhodes grass. As a result of relying on herbicides such as glyphosate and on taking tillage out of the system, we've created an environment that's perfect for its proliferation. So we're really at a turning point in terms of agriculture and weed management, where we've got to think outside of the square. So some of the things that we need to be thinking about is, do we need to be applying some different tactics that maybe are a little more expensive, a little less convenient, but in the long run will help us to have effective weed control for the long term? So as I mentioned, we've got chemical and non-chemical options. I'm not going to spend much time talking about chemical, but you'll all be familiar with double knocks. We've had fantastic gains in efficacy of weed management on our weeds such as fleabane and Orland's barnyard grass and annual ryegrass using double knocks. Residual herbicides are certainly playing more of a role in our weed management. However, with residual herbicides, there are some concerns around plant backs for specific crops. And also, we've got so many different variables really impact on the efficacy of a residual herbicide. Spot spraying, certainly with weeds such as feathertop rhodes grass, which starts to develop in a paddock as patches across the field, spot spraying may be an effective option. I'll just go back there for a second. We also have weed sensing technology now, where we're able to target low density populations with herbicides that perhaps are too expensive to apply in a broad acre sense. So from a non-chemical perspective, I'm going to be talking today a bit about cover crops, crop competition. We'll talk about strategic tillage, strategic burning, and we'll also touch base on harvest weed seed control. So on your screen now, you should be able to see there are 8 confirmed species in the northern region that have resistance to glyphosate. So the herbicide that we all love to use, that we rely on very heavily, is now not effective on populations of 8 of our key weed species.
So Michael, just to interject for a minute, of those 8 species there, which do you rate as the biggest problem in the northern region in terms of the biggest problem glyphosate resistant species?
If you look at the southern area of the northern region, annual ryegrass would certainly be the most common. In terms of the more northern area of the northern region, probably almost barnyard grass. It's quite widespread, and because we have summer cropping as a dominant feature in that part of the region, in crops, especially in sorghum, we only have limited herbicide options available. So I would say almost barnyard grass is the key problem there. But you can see feathertop rose grass is now on the list. It's also one that's becoming more and more widespread, limited herbicide options for its control also.
Yep.
Okay, so other resistances that we have, and I'm not downplaying them at all, you can see there on your screen. So in addition to the glyphosate resistance, we have resistance across multiple modes of action and for some of our key species there. So you can see that herbicides have been fantastic and we've had some fantastic gains as a result of them. However, the negative part is we've really relied on them too heavily, and as a result we've got these resistances. So I'm going to hand it now over to Annie, who will talk about a resistance survey that she has been doing.
Okay, so as we've been talking about, one of the consequences of over-reliance on herbicides has been resistance. So this is one of the relatively recent incidences of resistance. So in 2014, Tony Cook and his team at New South Wales DPI first reported glyphosate-resistant populations of common sowthistle in the Liverpool Plains. So that's why this survey that I'm about to talk about was commissioned. In that photo, you can see there seedlings of resistant populations shooting back 21 days after being treated with glyphosate. So the way we went about this survey was slightly unconventional, which was to use volunteers to collect our samples. This was a really good approach because it got around the tricky issue of getting permission to go on properties, which can be quite difficult to do at times. It also meant that we had people with local knowledge who were there on the spot to collect the weed seeds when the time was right. And it also meant that we could promote the resistance issue directly to these growers because we were able to give them a report at the end of the testing so that they knew about their specific population. Now, there were a few drawbacks. Sometimes it's not easy to engage people to get volunteers to collect samples for you because we're all busy people with competing priorities. We were a little bit concerned about sampling bias, that most of our samples would come back from properties where people already suspected resistance. And we're also a little bit worried about sample quality. So to get around these concerns, we put together a really comprehensive kit that had all the material and all the information that people should need to collect a high quality sample, and we emphasised that it did need to be from populations where resistance was not necessarily suspected. So you can see there in that photo at the top, you can see the bags, the calico bags that we supplied with their individual numbers so that we wouldn't get them confused, and also a questionnaire which each collector needed to fill out, which was really helpful so that we could find out a bit of background information about the population. In that chart, that's the sort of chart that we provided to each person who provided a sample, so they could work out where their population sat in the resistance spectrum, and so that was a really good way of directly getting back to industry with information about resistance, and it's so a good thank you as well for giving us the sample. So I'll talk about the results now. So in this map you can see the locations where our samples were sent in from. I should mention too that we had quite a bit of assistance from New South Wales DPI with collecting these samples. So that's in addition to the samples sent in by volunteers. So you can see the locations where resistance and developing resistance is where they're located. And so far that seems to be a much bigger issue in New South Wales than in Queensland. But the big, I suppose, the take-home message is resistant glyphosate-resistant populations of sowthistle are not just in the original location where it was detected, which was in the Liverpool Plains. It's a bigger problem than we first thought. I suppose some good news is, though, that most populations that we tested do seem to continue to be susceptible to glyphosate. We'll emphasise that this was when they were treated at a small size and at an upper label rate. So with continuing to use glyphosate, it is important to target the weeds as soon as possible and with those robust rates, but don't forget that you need to rotate your mode of action, and you should certainly consider non-chemical modes of action when available to you. So I'll switch back to Michael now.
Just Annie, if I could just ask a question as you're switching over. Those populations in the Liverpool Plains where there's the big collection of resistant sowthistle, what sort of farming system, where did they evolve in that farming system? Is it in that chemical fallow phase, that long fallow phase?
Yeah, that's what we think is really where this resistance issue developed around, was the chemical fallow and the heavy reliance on glyphosate alone, probably for the last 10-15 years. So that's really how we think this how this problem started. Yeah,
thanks. And just a message to everyone out there listening in, yeah, feel free to get your questions coming in, and we haven't had any yet. I'm keeping an eye on the questions box. If you pop in a question, we'll stop in a couple of minutes and go through them. Okay.
Okay, thanks for that, Annie. Now we're going to move on to some of the non-chemical control tactics that I mentioned earlier. The first one is looking at strategic tillage. Now I know in the conservation agriculture system we've largely removed tillage. This is not about reintroducing tillage as a regular practice. It's definitely based on strategic application. You can see we've got a photo there of feathertop rhodes grass that's obviously escaped treatment. So using tillage in that sort of situation is a reactive approach where you've got a salvage operation. Even in that situation, you're going to have seed that's dropped on the soil surface, and it's important that we know what impact that tillage has on the seed bank and therefore future generations of feathertop rhodes grass. Therefore, we need to be considering the ecology of the target weeds. In particular, we need to look at weed emergence and seed persistence. So I'll present a little bit of information now on a few of our key weeds and some of the tillage work we've done. So here we're looking at the emergence of common sowthistle. And what we did is we buried sowthistle seed at different depths, so from the surface down to 10 centimetres, and over time we looked at the emergence from these depths. And it basically showed that sowthistle emerges from the top 2 centimetres of the soil. So this one here is the 2 centimetre depth. This one here is 1 centimetres, and at the top here you've got surface germinating. So seed that was buried at 5 and 10 centimetres, we didn't get any emergence. So from a tillage perspective, if you were cultivating in a paddock that had sowthistle, you would expect that a proportion of the seed would be buried below the depth from which it can emerge. Now we're looking at fleabane, and here we're looking at the persistence. So we used a similar approach where we buried fleabane seed at 3 different depths of 2, 5 and 10 centimetres, and then over time we removed that seed and tested its viability. So if you're looking here at the graph, you can see the duration of burial along the horizontal axis, and then on the vertical axis is the persistence or the percentage of viable seed sown. So after 1 year of burial, we had more rapid depletion of seed at 2 centimetres than we did at 10 centimetres. And if we go right along to 4 years, we still had a small percentage of fleabane were viable at both 5 and 10 centimetre burial depths. So while seed burial might be an option to reduce emergence of our weeds, in most cases it will increase the persistence of that seed. If we move on now to look...
Just to interject, is that sort of saying if you do go and use some tillage and you bury some seed, you want to leave it there for a good 5 years and not bring it back up?
That's exactly right, Pete. That's why it's important to be aware, particularly of the persistence issue. If you're burying seed, in most cases, that seed will remain persistent for a period of time, whereas if that seed remains on or near the soil surface, that persistence is much shorter, and as long as you get effective management of any emergence, your seed bank can actually be driven down much more quickly in a zero-till system.
Yep, right.
Okay, so looking now at 2 of our summer grasses, the purple lines here are feathertop rose grass and the orange lines are barnyard grass. We're looking here at seed persistence, and we're looking at the comparison between surface, so 0 or 0 to 2 centimetres, and 10 centimetres. I'm presenting this data to show you one of the anomalies or one of the differences that we find with both feathertop rose grass and windmill grass. And that anomaly, which we can take advantage of, is that even if seed of feathertop or windmill grass is buried, the persistence over time is very similar to what we find with surface lying seed. So you can see here, after 12 months, there is pretty much 0% seed persistence for both buried and surface lying seed. Compare that with barnyard grass. At 12 months, we have about 40% still viable at 10 centimetres, compared to about 16 or 17% when it's on the surface. Now that's something to take into account if you are applying cultivation for feathertop rose grass or windmill grass. If you go through and cultivate and you're able to stop emergence and stop any additional seed from coming onto that block, you should really be able to drive down your feathertop populations very quickly. Just quickly, some research that we've done over 4 different experiments. We've compared 4 tillage treatments that range from minimal disturbance with the harrow to quite severe disturbance with the one-way disc. What we did is we sowed little glass beads on the soil surface. We also sowed our target weed species on the soil surface. We then applied the tillage treatments as a single pass. We monitored emergence over time, and we also took soil cores to recover the beads and to find out where these beads had been distributed as a result of the tillage. So the beads were to mimic weed seeds, just made it a lot easier to recover. So what we found in relation to seed burial, so along the bottom here we've got the different tillage treatments. I've excluded the harrow treatment here, but we've got increasing seed burial as we go from the left to the right. So if we look, for example, at the one-way disc, there was a proportion of the glass beads let's see, it's about 50% were buried below a 5 centimetre depth, and only about 12% remained in the top 2 centimetres of the soil. So the type of tillage you apply will impact on the burial depth of seed. Now, how did this impact on the emergence of these various weeds? What I'm showing you now is the data from experiment 1. You can see the range of different weed species that we looked at, from fleabane to our summer grasses. And you can see, generally speaking, as we increase the intensity of tillage, so from our harrows down to our one-ways, we got a reduction in the emergence of all of the species. Now this relates back to the seed burial depth. The other thing I want to point out here, in a zero-till system, the emergence that we got was up at this 100%. So in this season, we got reduction in emergence as a result of applying tillage. However, we did get different results across our different years. So this again is trial 1. We got reduction. Now, sorry, here we're just looking at common sowthistle. So we got reduction in common sowthistle for all of our treatments. Trial 2, so this was the subsequent year, we got an increase in sowthistle under the harrow and gyral treatment. Trial 3, an increase under the gyral, and in trial 4, we again got a reduction in emergence. Now, this can be quite easily explained. In trial 1 and trial 4, they were quite wet seasons. So after we applied the tillage treatments, we had a large flush of emergence from our zero-till plots. And that's because most of our weed seed was on the soil surface. In comparison, in the plots where we had applied cultivation, a proportion of that seed was buried. So when the favourable environment was there, only a proportion was at the layer in the soil that favoured germination. Now, in contrast, in trial 2 and 3, we had very dry seasons. So after we applied tillage, we had very little emergence from our zero-till plots. What did happen, though, is because we were burying seed into shallow layers in the harrow and gyral treatments, those seeds were preserved such that when we had a favourable environment, we then had an emergence, in this case, of common sowthistle. So the story with any of our weed management becomes a little bit complicated there. So tillage isn't always going to reduce emergence when you compare it to zero-till systems.
Just a comment there, Michael. That agrees with what we've seen in Western Australia actually for different weeds, and the one-way disc has been more effective than all the other machines there at burying weed seeds. The mouldboard plough is a step better again, but yeah, and a lot of growers in this part of the world are removing every second disc from a one-way disc plough and putting it in deep to get even better weed burial again. But the one-way disc is a standout tillage implement there, isn't it?
It is. And Pete, the other thing that we did, and I'm not presenting it today, is we looked at the impact of a second pass of a gyral following the offset disc and the one-way disc treatment, and we did find that for both of those treatments we did get seed returned back towards the soil surface, and as a result we then did get an additional flush of emergence.
Yeah, so if you bury the seeds, you've got to try and bury them deep and leave them down there, don't you?
Yeah, that's exactly right. Okay, so we'll move on. The next step in looking at tillage is to look at targeted tillage. So there's a current project which is a collaboration between the University of Sydney, University of Western Australia, University of Queensland and Queensland Department of Agriculture, is looking at combining weed detector technology with tine technology. So both technologies already exist, The idea, though, is combining them. And the application of this technology would potentially be as a third knock in a fallow. So you've gone through and you've applied your first and second knock. You've then got a low density of weeds present. You can go over the paddock and detect these surviving weeds, and instead of applying a herbicide, we chip out the weed with a hydraulically activated tine. So it's in the development stages at the moment. The benefit of this approach is you're causing very minimal soil disturbance across your paddock. The other thing, just to make you aware of, is robotic technology. So here you can see pictured the robot that the Queensland University of Technology have developed. They're looking at combining that with both chemical and non-chemical options for control of your weeds. So stay tuned in terms of both of these technologies.
Michael, where do you see that targeted tillage fitting best? Is it in that as a second knock in chemical fallow situations, perhaps?
It could either be the second or maybe a third knock, depending on how effective your first knock application has been, because really this will be targeting very low density weed populations. If the density of the population in the fallow is still quite high, you're going to be disturbing a fairly high proportion of soil across your paddock. So definitely the best fit is for low density populations, and I see it probably as a third knock in a field.
Right. Now, keep some questions coming in, everybody. I'm the only one asking questions at the moment, so make sure you type a question into the question box there if you have one. Okay, let's get going.
Okay, something that's a little bit outside of the square is cover crops. So we're looking here at cover crops in our summer fallow as an alternative to herbicide application. In the experiment that I'm going to be talking about, we looked at the effect of cover crops on ornless barnyard grass and feathertop rhodes grass. So in the table here, we're looking at the crop biomass, and you can see here the range of cover crops that we applied. So we've got cowpea and lablab and millet on their own and then in combination. And over here you can see the biomass of the cover crops. And basically anything that had French millet included had a larger biomass and therefore greater competition against our target weed species. If we look here now at weed biomass, I've combined it in this table for feathertop rhodes grass and ornless barnyard grass. Firstly, I need to explain we had 2 termination times for our cover crop. So termination time early was about a month before termination time late. So in terms of the impact on weed biomass, you can see here that, let me just click here, you can see that at the early termination time, any of the cover crop treatments with millet significantly reduced the weed biomass when compared to the lablab treatment. When we look at termination time 2, while it wasn't significant, that same trend was very obvious. If you look here for French millet, the weed biomass was greatly reduced when you compare it, for example, to cowpea and lablab. Now, we also had a treatment of chemical fallow that we included. So during the experiment, I think we had 3 treatments of glyphosate to control our barnyard grass and feathertop rhodes grass. So what's important then is what was the impact of these cover crops on our weed emergence pre and post the subsequent winter crop. Okay, so we've had the cover crop in summer, we've then got our winter crop. And after that winter crop, or before it and after, we counted emergence of these species. Now, we didn't get much feathertop rhodes grass emerge. And if you think about the slide I presented previously on the persistence of feathertop seed, would explain why we had very few feathertop come up. So I'm excluding feathertop, and I'm just looking at barnyard grass. Okay, so just down the side here, we've got the treatment. Our top treatment there was the chemical fallow, and then we've got each of the cover crop treatments with early and late termination. So in terms of total emergence of barnyard grass, pre and post winter crop, we found that there was a significant reduction in emergence for any of our late terminated cover crops. I suspect this may be a reflection of there being less moisture available for those weeds to germinate. When we look at wheat yield, we found that there was no significant difference across the treatments. So even when we look at the chemical fallow, where you would expect there to be more moisture available, therefore a higher yield, we didn't get any significant difference. However, when we removed that chemical fallow treatment from analysis and compared early versus late termination treatments, we did find that there was an increased wheat yield following early termination of the cover crops. Again, this would be a reflection of there being more moisture available when we terminated the cover crops early. There is going to be more research on cover crops and living mulches, which Charles Sturt University will be leading. So again, stay tuned in terms of advances in this area.
So Michael, you said that the early was about a month earlier than the late termination. How do you think you should time that early termination of the cover crop? What are you looking for in the weeds or the crop to time that termination?
The basis for our termination times were around seed set on the weed and also seed set on the crop. So as best we could, we tried to ensure that our early termination had no seed set on either. We did find, though, by the time we did our second termination, barnyard grass was just starting to set seed. So there may have been a very small number of seed that returned to the system, but we certainly didn't see that reflected in any of our emergence results. So really, we ideally would have terminated both before seed set, but unfortunately in the late one we had a bit of seed set occurring.
Yep, thanks.
Okay, so another one, and you'll notice with some of these approaches, it's nearly like we're going back in time. You know, we've talked already about cultivation, and you know, we've taken that out of our system. I'm now going to talk about burning, which might sound a bit extreme, but again, it's strategic burning. Okay, I've got a picture of feathertop rose grass up on the screen. You can also see some sowthistle in the background, but this picture is really representative of an early infestation of feathertop. You can see there on the plant, I don't know if you can see closely, but it's already set a lot of seed, but it's continuing to set seed. So one of the options when your plant is at this stage is to actually strategically burn. And I know on the downs here there's farmers who are doing this, and farmers who've invested in flamethrowers so that they can run around their paddocks and burn their feathertop. And I'll present now some data, and it's quite impressive, I think. We set up an experiment where we did burn individual patches of feathertop. We took seed samples off the soil surface, tested their viability. We took soil samples before burning and samples after burning. We tested the viability of these seed lots, and we found, you can see here on the screen, pre-burn, we had 7,500 viable feathertop rosegrass seed per square metre. In our post-burn samples, we had under 1,000. So you can see that burning reduced the viable seed number by about 93%. So that's pretty impressive. The other thing that burning does, it reduces the biomass of that feathertop rosegrass plant. So, for example, if you're wanting to come back and put a residual herbicide on in that paddock, if you've got feathertop rosegrass plants that are still there, like the skeleton of the plant, it's going to inhibit that herbicide from getting to the soil and from being of much use. So burning certainly is potentially an effective and useful tool for feathertop rosegrass. Okay, so I'll pass it now back to Annie to talk about harvest weed seed control.
Can I just interject before you do that? We've just got a question come up, and it's just going back to your cover crop presentation there. And the question was, what was the rainfall over summer in the year that the cover crop was in?
That's a very good question. We actually had it at a site where we were able to irrigate. Now, we only used irrigation to establish the cover crop. So I think we put on 1 inch of irrigation. I would have to check to see exactly what rainfall we had during the cover crop, but it was above average of what you'd expect. So the environment in which we did this experiment was quite a favourable environment for cover cropping. Again, there are concerns around if you do this in a season where rainfall is limited, what impact will that potentially have on your following crops? So this is just a snapshot of information. It was above average rainfall, but we still did get some detrimental impact on the subsequent crop.
So am I right in guessing that things like cover crops are going to be a trade-off between going and putting in a summer crop to grow for grain versus putting in a cover crop for a future benefit, and they both sort of need the same sort of season? Would that be about right?
I guess the way that we were looking at cover cropping is in your summer fallow in place of herbicides. So for example, if you've got a glyphosate resistant population of barnyard grass, so you're not able to rely on glyphosate, can that cover crop be used in the summer fallow? We generally in the northern region, I guess, have a fallow period between our summer and winter cropping. I guess it's more of an opportunity crop if you're able to do them in one season and then in the next. So you've got wheat one season and then go into sorghum, for example. So generally speaking, if you had a cover crop in a summer fallow, you may have to then have another fallow to have that stored moisture for your subsequent crop. And so that's, I guess, one of the negatives of having the cover crop. But in an above average rainfall season, maybe it has a fit.
Yeah, all right. Okay, yeah, keep the questions coming, everyone. We've got about 15 minutes to go, and we're handing back to Annie now, and I think there's only a few slides left, Annie, so yeah, we'll keep going and finish it off.
Okay, thanks, Peter. Now, this harvest weed seed control project is actually being led by Michael Walsh, and there's various components to it. I'll just be presenting on the component I've been most involved with, which is the commercial scale field trials. So the aim of these trials is to test harvest weed seed control on northern region weeds in real world scenarios. So using populations of naturally occurring weeds on working farms. Another aspect of the trials is to demonstrate the use of these techniques to the host farmers and any interested locals who want to come along and have a look. We're hoping to repeat these trials this winter in wheat and in chickpeas and in summer of next year. So we're looking for sites at the moment. If you've had any issues with wild oats this winter, please do let me know as soon as possible as we're scouting for our next round of farm sites. So the way we go about these trials is to find natural populations of the target weed species growing in crop. We've been doing this with the help of local agronomists, and there are some great guys out there who have made things much easier for us. We've also had some really good host farmers, so thanks to everyone out there who's been involved. So after we ID the sites, we go back at harvest site with all our own gear. We set up the treatments as shown in the slide, and we simulate each form of harvest weed seed control as nearly as possible. Our key indicator of the effectiveness of the various treatments is the emergence of our target weed species in the following season. So for winter harvest in 2015, we needed to wait until autumn and early winter of 2016 to go back to the site and count the emerging weeds. So this set of photos was taken this year, just before sowing the next crop. You can clearly see that the brassica seeds at harvest were concentrated into the windrows of the wheat and chickpea crops. We didn't burn the windrows. We left this to the host farmer to do or not do according to their own discretion. This next set of photos shows a similar thing, with brassica weeds emerging from the chaff residue that's been concentrated into the chaff dumps. These photos clearly illustrate that the weeds are being concentrated into the harvest residue as it exits the header at harvest time.
Can I just clarify, Annie, were the windrows actually burnt there?
No, so these windrows were not burnt. Neither of the windrows were burned. That's why there's so much weed emergence. It's actually worked out quite well because it shows clearly that where the weeds were concentrated at harvest time in the chaff as it exits the header. We didn't burn the windrows. We did this. It was a decision that we made mostly because of safety considerations, and also to get the farmer to agree to allow us to have the site on their property, because it's quite a big risk to allow a team of people to come and burn, especially if you've got high stubble loads. So that was the reason we didn't go back and burn at those sites. But it does show nicely, it's a good illustration that the weed seeds clearly were deposited into the chaff as it exits the header.
Absolutely. And the chickpeas there on the right, it looks like there's not a great deal of biomass. Do you think there would have been enough to burn?
Yeah, so that's at that particular site we had some very hungry locals. We had lots of emus and lots of roos who had eaten actually a lot of well, anything they could find really. So that's part of the reason why there was less biomass there. My thoughts would be that if you got there at the right time in a lot of sites, you would have enough to burn, and also you'd have less risk of you know, any of the risks of the fire escaping because of having the high biomass. So it's possibly a better option to burn in those chickpea situations.
And the chaff dump, had they been burned?
No, likewise, for the same reasons as I mentioned, they weren't burnt. So you'd imagine that you'd perhaps take, if you don't burn those chaff dumps, another option is to, you know, locate them elsewhere. You may even choose to feed them to livestock. Okay, so just getting back to this slide here. So apologies, this data is still transformed. It's a bit difficult to show the data clearly when it's back transformed because there was a fair bit of noise at these sites. So the reason that the data contained a fair bit of noise is just owing to the patchiness of the natural weed populations we were working with. So ideally you'd have a nice even scatter of weeds right across the block, but this isn't an easy find when you've got natural weed populations. So on the left you've got ryegrass emergence at a site where wheat had been harvested in 2015. And on the right you've got emergence of brassica at a site where chickpeas had been harvested in 2015. At the ryegrass site we're missing the chaff treatment, so that's the red one. You won't see that there because we got totally rained out of that site and we weren't able to finish all the treatments. But you can see that in both cases the integrated Harrington seed destructor worked very effectively to destroy the seeds. So if you compare that to the yellow bar, which is the which is the control treatment. So that's just the normal, the header operating as it would normally without any of the modifications or attachments to create the harvest weed seed control treatment. So if you compare this, the control situation, with the HSD or IHSD, it's you can quite clearly see a difference here at the ryegrass site and also here at this brassica site. So yeah, this wraps it up for me. But before I finish, I will just close with a request to please let me know of any sites where you've got wild oats looking to be a problem this winter harvest. We'd really love to talk to you about having a hosting a site on your farm. Back to Michael.
Okay, thank you, Annie. So we're just about done. I'll just briefly touch on crop competition as another non-chemical component that can be put into your system quite easily to combat your weed problems. So you can see the picture on the left. We've got barley growing there, and in the area between our plots, you've got fleabane that's absolutely loving the environment of no competition. For species such as fleabane and sowthistle, crop competition can be can have a wonderful effect on reducing in-crop infestations of these weeds. If you look at the graph over on the right, we're looking here at the number of fleabane seed heads in wheat that we've grown at 2 different crop densities and at 2 different row spacings. So if you look at the row spacing effect, so if we look here, we've got 50 centimetres at 50 wheat plants per square metre compared to the row spacing of 25 centimetres. You get a dramatic reduction in the number of fleabane seed heads. So it's very obvious that crop competition has provided a favourable result in this environment. When we do our crop competition work, initially we look at purely the effect of the crop, so we take herbicides out of the system. Now in the real world, very rarely would you rely just on crop competition. You would always, or in most cases, have an in-crop herbicide as well. And they would certainly have an additive effect on reducing your in-crop weed problems. Now, just to talk about some research that's just started, we've got funding from GRDC to explore competition effects in sorghum, in our winter and summer pulses, and also again in wheat and chickpea. So in the summer crops, we'll be concentrating predominantly on feathertop rhodes grass and almost barnyard grass, and in winter predominantly on sowthistle and flaxleaf fleabane. So some of the things we're going to be looking at, we'll start off quite simply. We'll look at row spacing and crop density effects. We'll then explore varietal differences. And then this is where we'll start looking at some things that are, I guess, a bit more innovative. So fertilizer placement, precision planting, and intercropping and companion planting. So stay tuned in terms of what we find there. But don't forget crop competition as an option. As I mentioned, it's probably one of the options that you can apply without too much added inconvenience. Yeah, you'll certainly get some wins if you use crop competition. Just lastly, I wanted to touch on integrated weed management and the principles of it. Basically, when you're onto a good thing, such as your glyphosate or your other herbicides, don't stick with it. Make sure that you use other tactics for your weed management, whether they be other chemical or non-chemical tactics. It's important too to use these in combination. Important to plan ahead. I think sometimes with weed management we can be very reactive. And that's understandable when we have salvage situations, for example, or when we've not been able to get onto the paddock. But where you can, try to plan ahead. From a resistance perspective, so both prevention and management, stopping seed set is critical. if you have a resistant weed in your population, you quite often can't identify that just by looking at that weed. What you can guarantee though is if you stop seed set on that individual survivor, you know that none of its progeny will go back into the system. For most of our weeds in the northern region, they are self-pollinated, which means that their progeny will be identical to the parent plant. So if you have, for example, a barnyard grass individual that's resistant to glyphosate, if you allow it to set seed and that seed goes back into the soil, you're perpetuating that resistance problem. On the other hand, if you don't let that individual set seed, you're stopping that resistance gene from spreading and becoming a problem in your paddock. It's also important to keep your weed numbers low. Herbicide resistance is really a numbers game. If you have a low density of weeds, the likelihood of a resistance gene being present is less than if you have a large density of weeds. But how you get to that low density is also important. The best way to get to that low density is by using multiple tactics for your weed management. Also, what is important is to stop your weed spread. So if you've got weeds in your non-cropping areas, it's important to control them using the principles of integrated weed management. There's numerous cases of resistance in non-cropped areas. And again, it's because of the over-reliance on herbicides. So that's basically where we'll leave it. We thank you very much for listening in today, and I'll hand it back over to Peter.
Thanks, Michael and Annie. Fantastic. Look, we've got a couple of minutes left, and there's a question there. Yeah, we can just finish up with any questions that anybody has at the moment. One question for Annie. In the harvest weed seed control research, there was tram lining versus burning. Can you just clarify what that is? Was the tram using a chaff deck to put weed seeds on the trams?
Yeah, so what we had was a special attachment that we had created for us by an engineering department at University of South Australia, I think it was. So they put together an attachment that we would fit to divert the chaff onto the in hopefully in a usual situation would be the permanent wheel tracks. So that's how we had that set up.
And any ideas about how it went compared to the burning options?
It's a little bit difficult to tell. Especially because we didn't burn, it would be nice to do this in a situation where we could burn. I think both, though, at the end of the day, were very effective in concentrating the weed seeds, so that whatever your follow-up control was to then destroy that chaff and the weed seeds in it, or whether or not you do that by burning or following up with some targeted spray operations, or just through the compaction on the wheel track. The effect we suspect would be more or less the same.
Yeah, and just looking at the national survey that Meulen did, putting weed seeds on permanent tram lines is a practice that there should be quite a bit of adoption happening in your part of the world. That was probably the main harvest weed seed control tool that growers in your part of the world said that they were likely to adopt.
Yeah, that's right. I think the numbers were about 15% already, and it's a relatively easy to adopt option, so we're hoping to see that grow in use.
Yeah, and it is a good practice. It's very easy for growers to achieve, and it doesn't involve burning, which a lot of people are opposed to, of course. Another question for Michael, I think. The 100 plants per square metre that you had in the barley trial, is that a typical sort of a plant density that you're targeting with barley in your part of the world?
Generally what we're doing in our crop competition experiments is we're trying to demonstrate the optimal environments in which you can maximise your competitiveness. And generally speaking, when we talk about wheat and barley, that 100 plants per square metre is what we target as the upper limit for achieving crop competition.
Yep.
So I think it equates to the million. Yeah, so I mean, it's certainly something that I think we're encouraging growers to explore. It equates to about the 1 million plants per hectare.
And just a bit further to that one, you know, I'm a big fan of crop competition, and that was great for the data you put up with the fleabane, high seeding rates, narrow row spacing, really suppressing fleabane. And you've told me in the past, Michael, that fleabane is a weed that is that really hates crop competition. Can you just elaborate on that and just tell us which other weeds in your area are the ones that really where crop competition is going to work really well?
Yeah, generally speaking, Pete, the broadleaf weeds probably are a little less competitive. So fleabane and sowthistle in particular. The grass weeds we haven't done too much work on. I know there's been some previous work using mimic weeds. So for example, instead of feathertop Rhodes grass, maybe they'll sow regular Rhodes grass. So we're still, I guess, got a fair bit of work to do in terms of the summer grasses, but they will be a bit more competitive than our broadleaf species. Just another thing to note, generally speaking, you get a much greater response in terms of competitiveness when you narrow your rows as opposed to increasing your crop density.
Yeah, yeah. So narrow rows you would choose over increasing seeding rate as a first option.
Yeah, correct.
Yeah.
You get a much better response when you narrow your rows, but you do get an additive response if you combine narrow row spacing with increased crop density.
Yeah, and we've seen that in other trials where at wide rows there's a bit of a maximum seed rate that sort of works, isn't there, because you're trying to cram a lot of seed into the same row.
One of the things, Pete, that's probably mostly applicable to the north of the northern region is we're really going to be exploring options for in sorghum. So sorghum, as you may be aware, is generally planted on wide rows of 1 metre row spacing. So you're really creating an environment that's poorly competitive. In combination with that, then we have our summer grasses. So we've got few herbicide options in crop, and we also have resistance in those summer grasses. So we're really hoping that in sorghum we might be able to demonstrate that crop competition is a useful tool. That may mean coming down to narrow row spacings of around 50 centimetres, but it's one of the gaps we have in our farming system where we think crop competition can really play a positive role.
Yeah, in my experience, crop competition doesn't really matter when your herbicides are working, but when the herbicides stop working, it really starts to matter. Now, one last question, and I don't think you guys will have the answer, but what experience do you have of years of repeating windrow burning in cross-harvested fields? So I'm guessing cross-harvested fields, if I'm right, is where you're harvesting at 90 degrees to the row direction. And there's not been a lot of windrow burning done in your part of the world, has there? So I'm guessing you may not have experienced that.
No, you're right, Pete. I think, you know, southern New South Wales, there's certainly windrow burning going on, and through Grain-Arana Alliance with Morris Street, he certainly would have some experience there. I'm not sure if there's been any work done on that cross-harvesting, so maybe that's something that we can look into a bit down the track once we know that windrowing and windrow burning is going to be effective in our farming systems and on our key weed species.
Yeah, thanks, Michael. Yeah, and there's not much cross-harvesting done in Western Australia where there's been a lot of windrow burning, but I am aware of people that have done it, and if the crop biomass is low enough, it does work, but in a high biomass cereal crop, you certainly end up burning the whole paddock. All right, we might wrap it up there. That's the hour up.